Have you ever been in a situation where you'd just like to have a task with a predefined result, without introducing an asynchronous process? This is where pre-computed results are really handy. Currently, every time we search for a stock, the application goes ahead and calls the API. During the development process, this might be unnecessary. Consider that sometimes querying an API will actually cost money. In other situations, you may want to write tests for the code that consumes the API without having to query the API each time you run the test. In those situations, it's common to set up a fake class, or what's known as a mock object. The only purpose of this class is to provide the same functionality as the real service. The class will provide the same method signatures, and instead of querying the API, you may just return some fake and predefined data. Instead of using the stock service, we're going to introduce a mock object. The mock object and the real stock service will both share the same interface. This means they'll have the same contract. If we use the interface throughout the application, the code won't have to care about if it's the real service or the mock object. The mock stock service will implement the interface and have a few predefined stocks that all live in memory. This will just make it easier for us to run the application and try a few things out without always querying the API. To implement the interface, we must implement its methods. The method signature specifies that we must return a task of an IEnumerable that contains the stock prices. This makes sense because the consumer of the method expects this to be asynchronous. Since we are creating all the sample data in an in-memory list of stock prices, there's no real reason for us to run a task and add the async and await keywords. In these situations, we want to simply return the object wrapped in a task without running anything asynchronously. There are a few ways for us to mimic the behavior of a result retrieved through an asynchronous operation without running anything asynchronously. The task class comes with some useful functionality. For instance, you can construct a task that's already marked as completed by using the static property completed_task on the task class. You normally do this when you override a method or implement an interface that requires you to return a task, but your method doesn't run anything asynchronously. Therefore, you don't care about starting a new task, nor do you want to mark the method with the async keyword. You'd simply want to indicate to the caller that everything completed successfully without changing the method signature. There are also other static methods on the task to construct a specific task for different scenarios. You could construct a task that is marked as cancelled or a task with an exception, all of them without running anything asynchronously. We'd like to return a list of stock prices as a result on a task without running a new task or adding the async and await keywords. Adding the async and await keywords in this situation is a bit unnecessary, as it introduces things like a state machine, which just adds a lot of overhead that we don't need. Instead, we'll use the method task.fromResult and pass the filtered list of stock prices as the parameter. This creates a task, which is marked as completed with a result of the search stock prices stored inside of it. This allows us to represent a completed task with a result without running anything asynchronously. We've now introduced a mocked version of the stock service. You can now replace the stock service with the mock stock service, and for anywhere where the iStock service was used, you could simply pass an instance of the mock stock service. Consuming this mocked service is identical to the real one, as they both implement the same interface. When you search for the stocks available in the in-memory collection, you can see that you get the mocked data, and it only took a few milliseconds. That certainly indicates that it used the in-memory data, instead of querying the API, which was a lot slower. This is a great addition, and a great way for us to work with our asynchronous libraries in testing, or in situations where we don't really want to introduce any asynchronous principles. Speaking of testing, let's add a test project to the solution and write a test against the mock stock service. This is just to show you how you can use asynchronous principles in test projects as well. Go ahead and add a new project. You can choose to add an MS test project. Let's call this stockanalyzer.tests. We can now write a test class for the mock stock service. Normally, you write a test for methods that use the interface iStock service and pass the mock stock service into that, but I'd like to focus on using asynchronous tests. Therefore, we'll just keep it simple. Let's create a test that checks that we can load all the Microsoft stocks through the stock service. We'll create an instance of the mocked stock service. We can now query the in-memory stock service. As this returns a task, we can use the async and await keywords. Let's also add a few asserts to make sure that we grab the correct amount of stocks from this mocked service. This would also be a good point to assert other things that might be relevant to the application. We can now run the test and make sure that it works properly. This shows that we can use async and await, even when we are writing tests. This is extremely beneficial, as a lot of the code that we write nowadays is going to be asynchronous. And being able to test our code is crucial to the success of our applications. Using pre-computed results with the tasks will certainly help us achieve this.